Here are your notes for astronomy. Section number 2, we already talked about why do we have seasons, because the Earth is tilted. We just did a lab on daylight. That lab is now due, so please get that lab handed in. We're now going to take notes on daylight and Earth science holidays together as one. So if you would open up your notes to page 21, it looks like this page, and on page 23, we're going to work on these two together. So let's start off. We notice that we have the Earth has an axis that is tilted. It's not straight up and down in relationship to the sun. It is not perfectly perpendicular to the sun. It's tilted. That tilt is 23.5 degrees. So we already saw that tilt causes our seasons. One of the things we notice with our seasons is the changing length of daylight. So that's going to be our focus today. And as we rotate, the Earth we rotate into daytime and into nighttime, out of nighttime into daytime. The line that separates night from day is not in line with the poles, but it's in line with the sun. So as the sun shines if any light shines on a ball, half of it's going to be lit and half of it's going to be dark. The line that separates the night from the day is called the terminator. One side is going to be daytime, the side facing the sun, and that side's nighttime. So as you shade this in, please make sure that your line that separates the night from the day goes straight up and down. As the Earth spins, we're going to spin into the daytime, into the nighttime. We're going to draw a couple lines on here. The first one I want to draw is where we live in Rochester. So if this is North America, we're right about here. So as you draw this line, we want to start up there. We want it to be parallel to the equator right here. Just have it curve and finish there. Make sure it's north or above this line right here. So this is going to represent where we live, 43 degrees north of the equator. Here's the equator, 0 degrees, right? 90 degrees up here would be at the North Pole. On this day, you can see that the line in the yellow, or the daytime, is longer than the line here. On this day, we're going to get 15 hours of daylight and 9 hours of nighttime on this specific day. Now, you already know what day this is. The day when the northern hemisphere is pointed towards the sun is June 21st. So we already know we're talking about June 21st. And sure enough, on that day, we have a longer daytime than we do of nighttime. That's true of every place in the northern hemisphere, that the day is longer than night, as we saw with our labs. So notice that on all of these graphs in the northern hemisphere, June 21st right here is the longest day of the year. Long day of the year on June 21st. June 21st, longest day of the year. June 21st. Well, no dates on that one. June 21st, longest day of the year. June 21st. Everything in the northern hemisphere has its longest day on June 21st. Even when we get down pretty low towards the equator, we can still see how here in Puerto Rico, June 21st is our longest day of the year. Let's go a little bit further north. What if we head up here? Imagine if you lived north of this line right here. Well, that line right there is the Arctic Circle. You can see this information over here on the previous page, page 20, to give you information about what those lines are. There's the Arctic Circle. If you live at or north of the Arctic Circle in this area, as the Earth rotates and spins around, you never spin into the nighttime. You just spin around here. An example of that is Hammerfest, Norway. Hammerfest, Norway is one of the graphs we have up on the wall. they have a month where the sun never sets, which is centered on June 21st, the beginning of June and the beginning of July. From the middle of June to the beginning of July, they have 24 hours of daylight where the sun does not set. What a strange place. Let's head on south and head to the equator. At the equator, well, the equator is equal. It's going to be 12 hours of daylight and 12 hours of nighttime on June 21st because it's the equator. Everything's equal. If we head further south, maybe a place comparable to 43 degrees north, what if we went to 43 degrees south of the equator? We follow that line, it's the exact opposite. On this day, the southern hemisphere has their winter. So June 21st, remember we talked about the tilt of the earth causes the seasons. So the southern hemisphere on June 21st is tilted away from the sun. That's their winter. They have very short days. So they have 15 hours of nighttime, just 9 hours of sunlight on June 21st. Notice the similarities. Here I have the sun shining on the earth. The earth is tilted towards the sun, June 21st. Here's the sun shining on the earth. The earth is, northern hemisphere is tilted towards the sun. It's June 21st. And let's flip over to page 23. We've got 4 points in the earth's orbit around the sun. Point A is where the northern hemisphere is pointed towards the sun. That's going to be June 21st. So let's jump over to page 23 now, and let's label this day June 21st. We can fill out that chart down at the bottom. Point A's date, June 21st. That date has a name. We call it the summer solstice. Maybe you already knew that. Solstice comes from sun, solar, still. The sun stays still. The direct ray of the sun. Well, let's spend a little bit of time on that. If I was to draw a line directly from the sun onto the earth, if I asked you, where does the sun hit the earth perfectly centered? Most of us would say the equator, and that is true if the earth weren't tilted. If the earth weren't tilted, that would be true, but you'll notice here that it hits a little bit above the equator. Let's go back to page 22 and draw that on there. So this ray right here, we call the direct or vertical ray of the sun. It's the one that hits the earth perfectly right in the middle. Meaning if you were standing right here, you would have the sun directly above your head. Notice that it's not hitting right at the equator. It's hitting a little bit above the equator because the equator has moved out of the way because of the Earth's tilt. Well, if the Earth's tilt is 23.5 degrees, the equator has moved 23.5 degrees out of the way, which means we're hitting this line right here is where the direct ray of the sun is hitting. You guys know that line better as the Tropic of Cancer. Which is 23.5 degrees, right? It's 20 because the equator is tilted out of the way. The Earth is tilted 23.5 degrees. So the equator has moved 23.5 degrees out of the way. So this is 23.5 degrees north of the equator. That's where the Tropic of Cancer is. And we already know that we've gotten 15 hours of daylight on that day. So June 21st, it's our first day of summer. The direct ray of the sun is striking right at the Tropic of Cancer. The northern hemisphere is tilted towards the sun. It's our first day of summer. It's the first day of winter for those in the southern hemisphere. Remember, southern hemisphere, first day of winter for them, first day of summer for us. So if you were filling this out in Sydney, Australia, you would say June 21st, winter solstice. Sun still hits the Tropic of Cancer. You're only getting 9 hours, assuming it was at 43 degrees south. All right, that's June 21st. You know the next day, too. on page 21, because if this is June 21st, when the northern hemisphere is tilted away from the sun, northern hemisphere tilted away from the sun, that's going to be December 21st. So here we have the sun shining on the earth. This is in June 21st. This is going to be December 21st. And let's put our day and night in here. The line that separates day from night, remember, is straight up and down. And just as before, the Earth is rotating around. And as we rotate into night, into day, into night, into day. Let's take a look at some of the same places that we looked at here, starting with where we live at 43 degrees north. Now at 43 degrees north, you'll notice that we spend much less time in the daylight. As a matter of fact, it turns out to be 9 hours as opposed to 15 hours of night. You've experienced these days. You remember these days. These are the days where you come to school and it's dark out. You're walking into school. School's starting at 7:35, and it is still dark. There's no sun. When you leave school at 2:05, maybe you've got another 2-3 hours of daylight. If you do an activity in the wintertime, whether it's a sport or another activity, by the time you leave, it's already dark. So you might come to school and it's dark, and you might leave school and it's dark. We're only getting 9 hours of daylight those days. This is our first day of winter, one of the longest days of the year. Conversely, look at this. Just like the people above the Arctic Circle. Now, the Arctic Circle, I didn't put the latitude up there. The Arctic Circle is the North Pole minus the tilt of the Earth, 66.5 degrees. And again, you can see that if you want to run over to page 20, you'll see 66.5 degrees for the Arctic Circle. So that Arctic Circle, anything north of 66.5 degrees, you had 24 hours of daylight. 6 months later, look what happens if you're north of that line. You spin all you want, you're never going to hit daylight. You're getting 24 hours of nighttime now. Where earlier, 6 months earlier, when you're tilted towards the sun, you're getting 24 hours of light. We also looked at the equator, and the reason the equator is called the equator is everything's equal, 12 hours of daylight, 12 hours of nighttime. As a matter of fact, it doesn't matter what day of the year it is. The equator is going to get 12 and 12. So just think that in your head. Equator, equal, things are equal. Notice the northern hemisphere tilted away from the sun. Here's the sun's rays coming in. Northern hemisphere tilted away. It's our first day of winter. It's the first day of summer down here. If we look at that 43 degrees south again, they're getting a lot more daylight, 15 hours of daylight and just 9 hours of darkness. That's their first day of summer. And here we can see the South Pole. There's the Antarctic Circle. There's the South Pole getting 24 hours of daylight, where 6 months earlier, if you were down by the South Pole, you're getting 24 hours of darkness. Let's take this day here and correspond to page 23. So first day of summer, June 21st was point A. 6 months later, look what's happening to the northern hemisphere. The northern hemisphere is now tilted away from the sun. So this is going to be our first day of winter. we fill out this chart, we're talking about position C. Position C, we know, is December 21st. Instead of the summer solstice, we call it the winter solstice. And we're getting 9 hours of daylight on that day. Now, of course, if you're in the southern hemisphere, you call these days different things. In the southern hemisphere, December 21st is their summer solstice. Seasons are opposite. Look what's got it happening. Southern hemisphere tilted towards the sun, so it would be their first day of summer. Northern hemisphere tilted away from the sun, their first day of winter. Take a look at that direct ray. Where's the direct ray hitting now? Again, it's not going to be hitting right at the equator. Now the direct ray is hitting a little south of the equator. And you know how much south of the equator it's hitting? 23.5 degrees south of the equator. We call 23.5 degrees south of the equator, not the Tropic of Cancer, but look up on the wall. Cancer is in the front of the room, and the back of the room is Capricorn. That's 23.5 degrees south of the equator. Notice the 23.5 degrees. That's all based on the tilt of the Earth. If the Earth was tilted more, then this would be, if the Earth was tilted 30 degrees, this would be 30 degrees north, 30 degrees south. The tilt is only 23.5. Well, we're missing some information because there's 4 Earth science holidays, points A, B, C, and D. Yet over here, our focus was just on June 21st and December 21st. So on June 21st, the direct ray of the sun's hitting right here in the Tropic of Cancer. Here you can see it's hitting below the equator. There's the Tropic of Capricorn. That's that direct ray. So if you want the sun directly over your head on December 21st, you've got to head down here to the Tropic of Capricorn. We do have 2 other days, and they represent the first day of spring and the first day of fall. Can you tell which one, points B and D, is fall and which one is spring? You can tell if you remember how the Earth revolves around the sun. The Earth revolves in a counterclockwise motion. So knowing that June is here, June, July, August, this must be fall, right? Because after summer comes fall, then winter. So this is our first day of fall. And that happens on September 21st. So point B is going to be September 21st. We call this day the fall equinox. Equinox, equal night. Day and night are equal. Everybody on the Earth gets 12 hours of daylight. Everybody on the Earth getting 12 hours of daylight on that day. If you remember looking at these graphs, September 21st, 12 hours. Doesn't matter where I go around the world. September 21st, 12 hours. September 21st, 12 hours. If you're still working on the lab and you're looking for something that a similarity, something that compares the graphs, September 21st is always 12 hours. September 21st, 12 hours. That's the northern hemisphere. Head on down to the southern hemisphere. September 21st, 12 hours. September 21st, 12 hours. For everyone, September 21st is 12 hours. The entire world. The direct ray of the sun is then going to be hitting right at the equator. So hopefully you're hearing some of the similarities. Equinox, equator, day and night are equal. The spring equinox, it's March 21st Direct ray lands on the equator, 12 hours a day and night. Maybe you remember balancing an egg on its end on March 21st. And I said, you can balance an egg on its end today. It's the first day of spring. Well, it turns out you can balance an egg on its end on any day of the year. It's not just, I didn't say it was just that day. It doesn't matter. There's a misconception that you can only do it on an equinox, but that's not the case any day. Right now, you can go and balance an egg on its end. If we could just get that last diagram up here, if the sun is shining on point D, the vertical ray is going to hit right at the equator. So here I have the direct ray coming from the sun. It's going to land right on the equator that day. Notice that the tilt of the earth, it's not tilted away from the sun like in December. It's not tilted towards the sun like in June. This is an equinox, first day of spring. This is going to be March 21st. So there are your notes for page 21 and 23 as well. Now turn to page 22. So we just took the notes on page 23. Here's page 22. Answer these questions except for question 2. We're not ready for 2 just yet. So 1, 3, 4, 5. Come back when you're done. Pause this now. Come back when you're done, and we'll go over the answers. Question number 1 says, if the tilt of the Earth's axis were decreased from 23.5 degrees to 15 degrees, New York State's winters would become. So if we go back to our notes, we already kind of wrote this information down. We said we have seasons because the Earth is tilted. If there was no tilt, we wouldn't have seasons. If there was more tilt, well, then the seasons, not that there'd be more seasons, is that the seasons would be more intense, that our summers would be even warmer and our winters would be even cooler. This question is not asking about more tilt. We're saying, what if we had less of a tilt? Well, we'd still have summer, but our summers would be a little bit cooler. We still have winter, but our winters would be a little bit warmer. So let's take a look at the answers. Correct answer is winters would become a little bit warmer and our summers would become a little bit cooler. So the correct answer to 1 is 4. Question 3. Before I even look, I see that the sun's rays are shining in this direction. There's day, there's night. The northern hemisphere is tilted away from the sun. Northern hemisphere tilted away from the sun, that's going to represent our first day of winter, December 21st. Answer 3 is 1. Question 4, which location in Earth's orbit represents the first day of fall for an observer in Pennsylvania? Well, we could simply just take a look at this. This matches, I guess doesn't match the letters, but I know that this is going to be June 21st. Over here is December 21st. And they give us these arrows, which let us know that the Earth is rotating counterclockwise. So June, July, August. Here's my September 21st. There's my first day of fall. Don't be confused by this in Pennsylvania. As long as it's in the northern hemisphere, that's going to be the case. The first day of fall in the southern hemisphere would be A, but for us, it'd be choice C. And finally, 5, on which day of the year does the sun reach the greatest altitude, meaning how high does the sun get? So if you remember in the beginning of the year, we talked about angle of insolation. And we mentioned that the sun is higher in the sky. We even mentioned June 21st. We drew a person there and we said for June 21st, the sun is higher in the sky, hitting that person at a higher angle than someone on December 21st. For them, the sun's going to be a little bit lower in the sky. So the reason this happens is because of the tilt of the Earth. Not only is the day longer on June 21st, but the sun is higher in the sky. So our greatest altitude, and again, it doesn't matter if it's in New York City or Pennsylvania, as long as it's in the northern hemisphere, it's going to be June 21st. 5 is 1.